So we will see the measurement of angles. Okay. So how do we measure angle? In all our classes we saw angles are measured in terms of degrees. Okay. So one complete rotation corresponds to 360 degree. Okay. This is different from the way we count the numbers, because when we count the numbers we count up to 10. Correct? Then 11, 12, 13 it goes up to 100, 1000. So that's why when we write the numbers also, when we write suppose 523.782 for example. So this is the one place, 10th, is the ones, tens, hundreds, and this is 10th, 1/10, 1 by 100, 1 by 1000, it goes like that. Okay, so because everything is, so this is all based on because this is 1 by 10th, then 1 by 100th, this is 1 by 1000. So these are what we call as a base 10 system, because the 10 is our base numbers. Okay, based on 10 we will do that. So but on the other hand, if you see, if I go with the base 10 kind of system, I would call one complete rotation as 100 degree. But normally we don't have. We call one full complete, then only I can divide this into finer and finer thing. But here what happened, one complete rotation we call as a 360 degree. Okay. So this is something not a base 10 system. Okay. We call this, we will see this is a base 60 system, 60 base system. Why? Yeah. Let us find an answer soon. So when I say one complete rotation corresponds to 360 degree, then I can always say what is the rotation amounting for 1 degree. So I can divide this into 360 sections that define your 1 degree. Okay, so then I am going to have a definition for 1 degree. So this is 1 degree. Now if I want to have finer things within this 1 degree, so then what am I going to divide it? So how the way in a sexagesimal, this way of defining the angle, which is 360 degree, this is called as your sexagesimal system. Okay, sexagesimal system is not based on system, it is based on 360 degree. One complete rotation corresponds to 360 degree. So then I can define a 1 degree, what is the amount of angle. Now if I want a smaller angle, fractional angle within this 1 degree, what am I going to do is I am going to divide this 1 degree into 60 smaller units, and that unit I am going to call it as a 1 minute, and the symbol is this. 1 minute is equal to 1 degree divided by 60. Okay, so this is different from the minute what we see it in the clock. The reason is that is a measurement of time and this is a measurement of angle, so they both are not same. Okay, though we call both of them as minutes, and we will say further also we will say seconds, but they both are not same. Okay, that is measure of time, this is measurement of angle. So symbol is this. There what we call in the clock we write 1 minute as 1 minute. We don't write it as 1 second, 1 minute like this. So now so this will correspond to some 60 divisions. I want to get a final division of that angle. Then I can always divide this further. So then what I am going to call? I am going to call it as 1 second. The double quote there. So that is going to be 1 minute divided by 60. So I am going to keep on dividing by 60. Okay. So this will be equal to 1 degree divided by 3600. Correct. So this corresponds to 1 second. So then that's the way I am going to define an angle. So the angle can be defined in degrees, minutes and seconds. Okay, so this type of measuring the angle is called as your sexagesimal system. Okay, so and this is very different from a base 10 system. I will show you. For example, I am going to give you an angle 32.5 degree. Okay, and I want to express this term in terms of your minutes and seconds. So what I am going to do, so this will be equal to 32 degree plus 0.5 degree, correct? So that is equal to 32 degree plus 0.5 into 60, correct, 60 minutes. Okay, so that is going to be 32 degree and 30 minutes. So this is the way we write. Suppose I have another one number, 32.53, let us keep. Degree. So then what I am going to have, so this will be equal to 32 degree plus 0.53 degree. Okay, so if you want to convert it into minutes, I have to multiply by 60. Am I right? So that is a minute. So what it will be, tell me?
31.8.
32 degree plus 31.8 minutes. Okay, or I can write it as 32 degree 31 minutes plus 0.8 minutes, right? I want to write it in seconds, so you call it to 60 seconds. Okay, so what this will be, tell me?
32 degrees, 31 minutes, 48 seconds.
32 degree 31 minutes and 48
Seconds.
So 32.53 degree is equal to 32 degree 31 minutes and 48 seconds. So if you see carefully, in normal decimals when we write, okay, so this is 1 by 10th, right? So we always multiply by 10 here. 10 and 20 and 10 and 100 and all. But here what we are doing, we are going to multiply by 60. So this is what we call the 60 base system. Okay. So angles are usually measured in this hexadecimal system. And you want to know the history? Okay. So why this hexadecimals? Why we use these angles for a hexadecimal system? It originates from Babylonians, because Babylonians are the masters in geometry, and the way they used to, because normal way we suppose Indo-Arabic system, we count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10 base system. But the Babylonian countings were different. The Babylonian counts on 60 base system. How do they count 60 base system? They count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they use this for the another multiple. So this 12 and this 5. So this is for pointing, and this is for number. Okay? So 5 into 12 will give you 60. So this is the way the Babylonians counted. So Babylonians were able to count up to 60 and then go for the next number. So that's why they got into the 60 base system, and they were the masters in geometry. So that's what all the angles, we still stick to the hexadecimal system. Okay, but this system, so we also visualize, because we know that when a complete circle is 360 degree and a straight line, the angle between the two rays is 180 degree. We all very well accustomed with this notation. Okay, but when I want to do some mathematical calculations, this is not going to be correct. Okay, because 0.5, this is not 0.5 means 1 by 1/10 of it. Okay, it's not a 1/10 position, it's not 1 by 100 position. Because the 60 base systems. Okay, 1/60th of the position, 3600 of this position. So this is not a base 10 system. So when I use with other calculations, this is going to have a conflict. Because other systems we have a base 10 system, but here we don't have the base 10 system. So this angle measurement, this hexadecimal measurement is not convenient when I want to combine, mix up all the mathematical quantities. So we have to redefine another measurement of angle. So let us define a new system by which angle can be measured. So what am I going to do is, so let us have, so we have this coordinate system, x minus x, y minus y, origin O. So I'm going to have a circle. Let us have a circle of radius, say capital R. Okay. I define an angle for which this arc length is also equal to R. Okay, and I call that angle as 1 radian. Okay, so this is not degrees. I am going to define a new angle system. I am going to have another way how I am going to measure the angle. So 1 radian. So now if you see, so now what is the condition? The arc length should be equal to the radius. Now you may think, if I keep different radius, this angle is going to change. We will show that it will not. So this angle will be independent of this radius. So that we will see it soon. We'll see it soon. So first we will see. So now we have defined a new angle measure, which is not your degrees, hexadecimal measure. So we are having a new measure, and this type of measurement is called as your circular system. In a hexadecimal system we use degrees, and in a circular system we use radian. Okay, for degrees, this notation is small 0 on the top. For radian, it's a small c on the top. So this is the way we denote. Okay, so now let us see, because both of them are angle measurement. So we have to, can be related. Okay. So for time being, let us assume this is not going to depend upon radius. Okay, whatever the radius you take, this angle is going to be fixed. We will prove it soon. Before that, let us see this angle. So now I want to measure. I want to see how this 1 radian is connected to the sexagesimal system. How these two measurements angles, because they both are going to measure the same angle, how they are going to be connected. So let us take, for example, so let me take this point as A, B, and this point as C. Okay. So what is the measurement of this whole angle? And I will call this one also. We don't need this angle. Correct. Yeah. What is the measurement of this whole angle?
180.
That is 180 degree. Correct. So, and what is the length of the arc corresponding to this 180 degree? Pi r. Correct. So, and okay. So now, so for 180 degree, so this is the angle. This is the arc length. 180 degree corresponds to pi r. Correct? Similarly, 360 degree corresponds to
2 pi r.
2 pi r. So 90 degree corresponds to pi r by 2. So you can see they both are actually proportional. Correct? Angle and these are basically proportional to each other. So then the angle and arc length are proportional. So then I will take, suppose let us take this angle, that is the angle BOA. For angle BOA, the length is what? R. Okay? And for the angle AOC, what is the length? AOC. Huh?
This is pi
R.
pi r.
Correct? So therefore, so now these are proportional. So the ratios has to be equal. Am I right? Therefore, the angle BOA divided by angle AOC is equal to R divided by pi r. So that's going to become 1 by pi. Correct? R cancels off. Now what is angle BOA? That's what we are calling it as a 1 radian. Am I right? So this is 1 radian divided by angle AOC is
180
degrees, 180 degrees. That is equal to 1 by pi. Okay? Or 1 radian is equal to 180 degree divided by pi. Okay? Got it? So now you see. So this is 1 radian. This relation relates how these two angle measurement systems are connected. Now if you see 1 radian, is there any value of function of r? Is r is there?
No.
So this is just an angle. You got it? So it doesn't have an angle. So 1 radian is not related to the radius of the circle. So it is independent of the radius of the circle. So this angle is going to be fixed. What it means is, if I take a smaller radius, okay, with a 1 radian, so this curve will be equal to this radius. Or if I take a longer one, so this radius, let me call it as R2, should be equal to this distance R2. Okay, so this angle is independent of the radius of the circle. So this is going to be purely a measure of an angle. So instead of this degree notation, I can always use this pi. What advantage of this? Because we will see, because this is not going to, this is 1 radian is not going to be a 60 base system. Okay, so we can always have a fraction of radians and all. Okay, and moreover, this have another convenience also, which we will see it now. So let me note down this equation, a relation. So this is an important relation by which your radian measure and your sexagesimal system are related. So you can convert also. For example, so then in your case, your 1 degree will be equal to pi by 180 radian. Okay, either of the way we can do that. Fine. So now, so there's an advantage of using this radian system. Why? We will see that. So let us try to find out something. Okay. So let us try to find the arc length. Okay. So how an arc length is defined in case of a radian based system, that is a circular system, and a sexagesimal system. So we know. So the arc length for 180 degree in the sexagesimal system is what? What is the arc length? Yeah. So for degree, arc length by 180 degree equal to how much? Pi r. Therefore, arc length by 1 degree is equal to how much?
Pi r by 180.
Pi r by 180. So now I am going to ask a question. So what will be the arc length corresponding to? So let me not remove from, let me have another one angle. So let us say, okay, let me call this angle. Okay. So what is the arc length corresponding to this angle theta? Okay. So then what is the arc length corresponding to the angle? Because I know 1 degree makes pi r by 180 degree. So arc length by theta degree will be equal to how much?
Pi
Tell me.
r theta by 180.
Okay. So this is the arc length. Now let us try to see the whole. This is based on which system? Sexagesimal system. So let us do the same thing in circular system. So in a circular system, 180 degree corresponds to 2 pi, right? Because we know that 180 degree, 180 degree corresponds to pi. Okay? Arc length by pi radian, correct? That's equal to how much? Pi r, right? So arc length by 1 radian equal to how much?
R.
Pi r by r, that is equal to r. That's what the definition of your radian also, because radian is what? That is the arc length. When your arc length is 1 radius of r, that's what your definition of your radian also. So anyway, that's okay, it's coming proper. So r, yeah. For arc length by theta radian will be equal to how much?
Theta r.
Theta r. Now did you see a difference? So this one and this one, this is in your sexagesimal system and this is by your circular system. And there's an advantage of having a circular system over the sexagesimal system is it's not the number of terms are more there. There is a pi sitting here, but here there is no pi. We know pi is an irrational number and we don't know what is the exact expression for pi. Okay, normally we approximate it as 22 by 7 or 3.14, whatever. But here, when you express in terms of radian, we escape out of the pi symbol. Okay, that's the advantage of your circular system. So, and it's not just arc. Let us find out the area also. So, suppose area. Okay, in the place of arc length, the same thing we'll find in area also. It becomes easier. Area area subtended by circle. I just write area by 180 degree. Okay. So what this will be? That will be equal to how much? Pi r square by 2. Okay. I told you you should never write 180 degree equal to pi r square by 2. This is mathematically wrong. Why? Left hand side is an angle, right hand side is an area, centimeter square. Even for arc length also, you should never write in the equations paper that 180 degree equal to pi r square. You have to write area subtended by 180 degree angle equal to pi r square by 2. Okay. Both the sides, left hand side and right hand side, should have the same units always. Area subtended by 180 degree is equal to pi r square by 2 because half semicircle. Okay, therefore 1 degree will be equal to how much? Pi r square divided by 360. Okay, therefore for theta degree will be equal to how much? Pi r square theta divided by 360. So this is the symbol. Now let us do the same thing for the radian based system. area subtended, I am writing it short, I am not writing fully. Area subtended by pi radian will be equal to, pi radian is same 180 degree, that will be equal to pi r square by 2. So 1 radian will be equal to, how much tell me? R square by 2.
By 2.
Correct? Because pi gets cancels off. Therefore, what theta radian will be equal to how much? Tell me.
Pi r square by 2.
No pi. R square theta by
R
2.
square
Okay, pi goes off.
by 2.
So again, you see when you define the area, there is no pi. Okay, so this is one of the advantage of using this circular system. So what normally when you are doing the mathematical calculations and all the calculations, we always use is radian measure. Even in your calculator, when you have the scientific calculator, sin theta, cos theta, by default it will be always in radian. When programming, computer programming and all, by default this will be always in the radian measure, because there you have to use only the decimal system. Okay, not about base 60 system. Okay, so but for us visualization, so what is it typically? You know the value pi is equal to how much? 3.141. Okay, so if I give you an angle as 3.14 radian, can you think of? Okay, so for visualization, we always say we know when it is 180 degree, it is straight. Okay, so for visualization purpose, it's easier to get the sexagesimal one. But on the other hand, for mathematical calculations, when you want to do, radian measure is better. Okay, so yeah, and now you know how to get transferred. How to transform between one system to another system. You know this is the relation. Let us do some examples. Okay, so let us try to find out. For example, let us try to say one number or one measurement of angle. Say something like 52 degree. 52 degree. If I want to convert it into radian measure, so what it will be? Tell me. So we know 1 degree is equal to pi by 180 radian. Okay. Therefore, 52 degree is equal to pi divided by 180 into 52 radian. Tell me what is the value?
0.907.
So pi you put 3.14, right? How much?
907.
907 radian. Okay. So this is the way you can. Okay, let me take for certain cases. Suppose 20, or let us write it as a 127.25 degree. How will you do that? Tell me. This is what? First you have to convert into sexagesimal system proper in terms of minutes and seconds. Okay. So, oh no, sorry. No, sorry. I'm going to give this one as 127 degree, 32 minutes and 10 seconds. First we have to convert it into the proper degrees, what are the in fractional, and then we have to equate it. So what will be this one, tell me? So 127 plus 32 by 60, that's in degrees, okay? And this also we have to write it as 10 divided by 3600, because this is a second. Second is 3600 degrees, 60 by 60. Okay, so what will be value, tell me?
127 plus 0.53.
127 plus 0.53 plus 1 by 360. How much?
0.0027.
0027. So this whole number is how much? 127.5327 degrees. Okay, now you got the number. Now you have to always convert it, right? So 127.5327 degrees is equal to how much? Pi by 180 into 127.5327. This is in radians. Okay, tell me what's the value?
2.225.
Give me 2.225 radians. So this is the way how you are. So similar way you can convert back also. Okay, convert back from, if I give in radian, you can always come. So let us do that also if you want. Let us take some radians. What is that? Okay, let me put up the radian as 2.99 or 2.82 radian. If you want to convert it into degrees. Okay, so what will be value? 2.82 radian is equal to, that will be, for degrees what happened? Radian 180 by pi,
180 by
right?
pi.
180 divided by pi into 2.82 degrees, right? Tell me what is the value? Use 3.14.
161.65.
161.65 degrees. Okay, now let us write it in seconds, minutes and seconds. So this is 161 degree, okay, and plus, how much it will be? Plus 65 into 60 minutes, right? So how much it will be in
39.
sorry, 0.65, 0.65 into 60 minutes. How much?
39.
That's it. Huh?
39.
So that is 161 degree, 39 minutes. If you have some more number, then you have to convert one more 60 and hit it in seconds. Cool. So this is the way angles are being measured. So what we learned is that angles are measured in two systems. One is hexadecimal system. That's where we use your degrees, 180 degree, 360 degrees for complete circle. And then other one we use is a circular system, where is the radian, using the radian. So normally radians is more a scientifically used system because it's not a 60 base system. We stick to a Western system. Okay.